pause that, shall we? Here we go. Yeah, nobody likes a preamble. We can get straight in with the slides.
Excellent. Can you guys all hear me all right? Yes, on this end, I assume. I'm assuming a thumbs up is a good sign. Excellent.
Yep.
So hello, everyone, and thanks for having us at this Argo community meeting event. So I'll essentially be talking about how we at Ladybug Tools have been using Argo within our new product called Pollination, and specifically how we're using Argo to run these reusable cloud workflows for environmental building simulations. So essentially, I'll kind of talk you through what pollination is and how it came about. I'll try and make that brief because we're really here about Argo. Then I'll talk about Queen Bee, which is our kind of home-cooked workflow schema. After that, I'll go over how we have integrated Queen Bee with Argo. And finally, once the talk's done, you can essentially ask us questions or give us comments or feedback on what you've seen. So Pollination essentially is a new cloud product built on top of Ladybug Tools for the AEC industry. So this is essentially the architecture, engineering, and construction industry. Ladybug Tools was born about 8 years ago as an open source collection of Python libraries to facilitate modeling complex buildings. And so Ladybug Tools is a suite of about 5 different tools which help with climate visualization, energy analysis, daylight analysis, airflow modeling, and increasingly urban scale modeling. And so a lot of the users essentially really like Ladybug Tools, and it grew to be quite a popular tool within that kind of niche industry because it made specialized environmental simulation expertise accessible. They were developed as plugins which can be integrated within current tools, and it really supported a lot of simulation engines which you could then mix and match to create relatively complex workflows. So they've been quite successful, and essentially their users really do like them. So there's a bunch of comments you can find on the web and stuff about people being quite happy about how much money they saved and all that kind of stuff. Now, over time, the 2 co-founders, Chris and Mustafa, essentially did some consulting and went around the world to kind of help people use their tools. And while they were doing that consulting, they realized they essentially gained a better understanding on how users were using or misusing these tools and what the kind of recurring pain points were with using these and trying to run these complex simulations. And so out of this, they essentially identified 4 pressing needs. The first was there is a need for this out-of-the-box cloud computing type solution. These workflows had to be shareable and reusable. So currently the way of sharing them was to share a specific file called a Grasshopper file, which is a specific bit of software. And the dependencies weren't packaged in. So all of that was really difficult. And you had the classic works on my machine, but not on yours. They wanted more tools to be accessible. And finally, all this stuff really had to be accessible from the web. So it was very difficult to run all these simulations and then show the results to your boss or your manager or whatever third parties were involved. And so this is how Pollination was born, essentially. So it's kind of designed as this cloud platform for collaboration, which really helps all these different parties make well-informed decisions together. So there we go. The kind of aspiration of what we're trying to get to, and to give you an idea what Pollination actually looks like. So the idea is we want users to be on their desktop and to use their CAD, so computational computer-aided design tools, or BIM, which is building information modeling tools. They would translate these to an analytical model, which is an open source JSON kind of format. We essentially then have our recipes, which are these kind of custom workflows we were talking about, and run them locally and then visualize these results, and we're all happy. The idea was then to be able to do the same thing in the cloud and using the same kind of system. So you'd have your analytical model, you'd have your recipes, you'd be able to view your model on the web to really debug it and understand what's going on. And then you'd also be able to run your simulations on the cloud using the exact same process and the exact same recipe. These results could then be fed back into your 3D model, as well as other analytics backends or softwares or whatever you wanted to do afterwards. And so as you can see, the keystone of this entire process really relies on this recipe object. So whatever in the middle of that screen here. And this object has to be shareable, executable in multiple environments. And finally, it really has to be reliable. So it has to execute in the same way everywhere. And so this is how Queen Bee was born. And so Queen Bee, as I explained previously, is our kind of workflow schema for local and cloud simulations. And so Queen Bee was very strongly inspired from Argo. I will be honest with you guys. We took some strong inspiration, and it was based on the kind of Argo Kubernetes object schema. We've changed things over time to really fit our needs, but yeah, it's been quite an interesting one. The Queen Bee schema itself is open source, so feel free to have a look at it on GitHub at the link I've pinged below. And there's quite a few docs on it, so hopefully it's relatively usable. Now, essentially what we wanted to achieve with Queen Bee was really making these reusable recipes, as I said. So first, these recipes had to be robust. And so we did this by essentially having a strong input-output system. So we had a type system for inputs and outputs, and we abstracted the concept of artifacts that exist in Argo. So where Argo only has parameters and artifacts, we then had like, ints, spools, JSON array, all that kind of, objects and arrays. And as opposed to artifacts, we had kind of files, folders, and paths. And rather than having things go directly to S3 or whatever source you're using, we just give the users this abstraction that we call a project folder, which kind of behaves a lot like a file system. Then these had to be shareable recipes. And so for this, we built a kind of package managing system, et cetera, to like manage, deploy, and download and version these recipes and plugins, as well as apply any kind of role-based access control to make certain recipes private, others public, and all that kind of stuff. Then they had to be pluggable. So by this, I mean that essentially a recipe is composed of a series of functions, and these functions are packaged and can be like imported relatively easily and dragged and dropped to really like create the functionality of the workflow that you're building. And recipes themselves can be used inside of a recipe. So you can have these kind of nested workflows being built relatively quickly. And the last thing, of course, is that they have to be cross-platform. So we really have to make it so that users can run their recipes both locally and then on the cloud if needed. And so the way we achieve this essentially, with this strong schema, what that allows us to do on top of that is we can also then provide this interface for users in different environments. So be it Rhino, which is a 3D CAD modeling software, Grasshopper, which is a Scratch-like programming interface with drag and drop nodes and stuff like that, or on the web where you just fill in a form as your inputs to your recipe and then run it as a simulation. So now the way these things get executed, of course, is so recipe needs to be executed either locally or on the cloud. And the way this is done locally is we essentially translate this recipe into a Luigi Python binary, essentially, which just runs and accepts the inputs that we give it and just runs the whole thing through and as we want it. And of course, the way it's going to run on the cloud for us is using Argo. And so this essentially is what brings us to this Queen Bee with Argo, which is, as we call, a match made in the cloud at this point. It's worth noting for those who are interested that we're currently we're running on Argo 2.12. That's mostly because the entire backend team is me and I'm doing a lot of stuff at the same time. So it's been difficult to upgrade day by day. So now I'll give you a couple ideas of like reasons as to why we decided to go for Argo, because as you know, there's quite a few different tools that allow you to run things on the cloud, like Luigi, Airflow, Daxter, AWS Step Functions, or Databricks and stuff like that. And so the main reasons for that were really that Argo, first of all, so Queen Bee requires this kind of DAG and loop-based workflow resolution so that we can really enable these expressive workflows that our users needed. Also needs to be able to essentially be able to schedule what I'd call obscure software. So a lot of simulation software, stuff for CF, computational fluid dynamics, might be quite old or quite specific to run on like odd machinery. It might require GPU and stuff like that. Some of the daylighting software has been updated properly for the last 10 years. And some of the energy software, such as Energy Plus, is written in Fortran. So we're not really in kind of like, AWS Lambda land. We can't really schedule these things that easily. And the last, of course, requirement was that it really had to be cloud agnostic because we've got these ambitions to enable our users to schedule simulations on their own cloud potentially in the future. And so Argo was perfect for us because it was container-based, so it could handle this odd scheduling behavior I was mentioning. It's got these very strong workflow primitives, which we could make use of. And it's Kubernetes native, which allows it to be cloud agnostic, and it's open source, which is always awesome. So yeah. Now, the way we essentially handle Argo is we translate our Queen Bee recipes into an Argo workflow. And so the way this is done is we've got a recipe, we've got our inputs, we transform, this combines into what we call a job object, and then we've got a library called Queen Bee Argo, which translates it into an Argo workflow. And so what happens during this process is we translate our abstractions, such as project folder, into an S3 or Google Cloud Storage sync. But keep this kind of like local file system abstraction working for the users. Some of the pain points here, which are worth noting, is that artifact resolution is like super hard. And I've made a couple of PRs to do with kind of really getting S3 to behave a bit more like a file system, which is not supposed to, but try and work around these as we could. A couple of other things which are a bit tricky is handling like injecting secrets, such as if there are like some specific like database requirements, like access points, or if they're using a specific container. That's stuff that we're kind of still to resolve and decide how we want to make work properly. Then translating from Argo back to Queen Bee is essentially pretty much the same process, but backwards. We take the recipe because we need to know a lot of information about the context that generated a specific node in the Argo workflow status object. We've got the job to know kind of where to point it. And finally, we've got the Argo workflow object. We combine these together and resolve all the stuff we need and translate them back into a job status object. And then we dump this into a database. One of the specific reasons we don't just use the Argo workflow object directly is really because we want to enrich a lot of the information, kind of recontextualize it with these strong input and output primitives we were mentioning. The idea is that will then help our downstream processes better explain to our users what happened or really let them see through this workflow. It also helps us kind of have a similar API when running locally or on the cloud. And so the way we schedule these simulations in practice, so we're currently running on Google Cloud, but it would work in quite a few different clouds. We're not using anything crazy. The first step is a user just submits a simulation to run through the Pollination API. So the user gives us their inputs as well as the recipe they want to use. We translate this and send it to the Argo server, which then schedules it using the standard controller API. We've then got essentially a workflow diff generator, which listens in on the Argo controller logs to essentially keep update events and pick update events for the server and dumps these update events into a pub subtopic, which then gets picked up by our simulation service, which will translate them back and dump them into a database for us. And once these are done back, then they can go on to produce further events that are translated and in our own pollination schema. Some of the advantages of doing this, as opposed to, again, just querying directly and translating on the fly, is that allows us to do instead of querying the Argo server directly for the update status, first of all, it means that we don't overload the Argo server when it's already doing quite a bit and stuff like that, especially if you have quite a lot of users using it. It also means that we're free to write our own query API and make some queries that are a bit more interesting to us and our users without having to make changes to the Argo server or request those changes to the Argo team. So yeah, some pain points of essentially this event-based state translation. Scraping events from Kubernetes is a bit unreliable or pretty difficult. And the reason for this, I think, is because the Argo controller essentially admits these update events very, very quick succession. And my understanding is that there's a bit of a kind of cache control system in Kubernetes, or at least that prevents overload of the server itself, such that these update events aren't necessarily, or might be combined such that we don't get the granular information that we were asking for initially. There's an issue for this. To be fair, it might have been resolved, might have not. There's maybe a way around it. For now, we figured we'd just use the logs and essentially parse them as we needed. We also prefer to batch these requests to the server once we get the logs to not overflow the Argo server. The translation then itself is also relatively complex in the sense that certain inputs or outputs for our DAGs require information from the nodes inside of it, as well as the source template, so the source Queen Bee recipe schema to be available to do the translation. This can again be a bit complex because it requires a lot of retrieval of information and combining of information at the right time. So it's not super stateless translation, it just made things a bit difficult. So yeah, and so now I've kind of gone through quite a bit relatively quickly. So I figured we'd just show you a bit of a live demo. Hopefully nothing breaks. We'll see how it goes. Wish me luck. So first I will take you to our application. So this is our pollination application. As I mentioned, so we've got these concept of recipes. So I'll show you a recipe first to give you an idea of what they're like. So let's take the annual daylight recipe. So as I mentioned, this recipe's got some information about it. It's got a series of inputs and a series of outputs, which are rather specific. And then we can essentially explore the recipe itself through this kind of node-based interface. And so at the moment, nothing's actually happened yet. This is just a template for how we want things to be executed. And so, for example, we can see there's a step here to create a folder, and we can actually check what this step does. And that is resolved within the plugin which we've used, which is the Honeybee Radiance plugin in this case. And this function specifically creates a Radiance folder, and this is the command for it. And then there'd be inputs and outputs below it and all that kind of stuff. So that's that. Then within that, we can also have recipes inside of recipes. So in this case, this is like a nested DAG where you've got annual daylight simulation that's actually running inside of our annual daylight object itself. And so this one just does some more granular stuff. as we can see. And finally, this exposes its own results at the end of it. So yeah, that's essentially our quick recipe viewer. Then our main place to run things essentially are inside of our, excuse me, we go into my profile, inside of our projects, where we really combine everything that we bring together. So essentially users have access to a file system, which we kind of give them. So they've got a folder with information in it and whatever they need. And in our case, we've got two things we're interested in. The first is our 3D model. So we've got a simple 3D model that we've got here, and the weather file that we're going to use to schedule it and simulate it. So as we do this, I can then schedule a new run for my account. Here, I can select my demo project, and I can select the annual daylight recipe we were talking about before. I'll now select my input. So I wanted this 2-room JSON object, which is this one here. So select this and select the weather file that I need for it, which is here. There are a couple of other inputs here which we could change. I'm going to leave them because I'm lazy, but essentially we could change them. And a quick description. So then this gets scheduled to run. And so now we know that we've got our run. It's been scheduled to run and it's happening. As a side note, we've got this, our Argo server kind of up and going, and we can see that this run has now been scheduled to run on our by Argo, and it's doing its own thing. Now the update speed at the moment is a bit late because this is our staging setting. So this run might be a bit slow to update. Oh no, it's updated pretty quickly. And so we can see that this UI is, it's essentially the same for now. But the information we've got is a bit different from what we've got in Argo, where essentially we've got a quick overview of what's happening, our inputs and outputs, and we then, this idea of like adding extra information to things is really so that we can resolve things like, this is, for example, a model file. And so we can say, cool, we can now resolve where that model is inside of our folder itself, for example. So yeah, that's essentially it. So this is how our simulation is running. Once it's done, it'll tell us it's done, and we'll have our outputs available here. If I go back to my project here, we can see that I've got a series of runs that have been running. This one is doing its thing. And I've got a series of runs with their own inputs and outputs here as I've run them, as well as the link to the recipe that originated them. I can then go back to, which was the annual daylight one I showed you previously. So yeah, I think that's pretty much us at this point for our live demo and how things work. If you guys have got any questions, of course, you're more than welcome to ask them. And as is mandatory, we're hiring, so please feel free to get in touch if you're interested in what we're doing or want to hear a bit more about it. Thank you very much.
Does anybody have any questions they would like to ask? Because I have one, but I want to give everybody else a chance to ask a question first. How do you do your graph?
The graph, which one do you mean? This one? Yeah.
So this is, what is this rendered with?
Oh, do you know what? I'm actually not 100% sure. This is our front-end engineer built it originally. Honestly, I'm not sure. Sorry. We're actually currently looking into using something different because we found something called Light Graph, which I'll show you really quickly. Light Graph would be something we'd use to actually help people build them themselves. So Light Graph provides this kind of recipe build, this builder interface, so you can drag and drop things and like connect them together and stuff like that. So yeah, if you've got updates and you're interested, we'll happily collaborate with you or like send you some feedback and have a chat about it once we've got progress on that aspect of it.
I'll have a look at this light graph, certainly. Does anybody else have any more questions they would like to ask before we move on to Sumit's presentation?
I actually have a question about the, there's one page on the slide saying Argo events. There's a Kubernetes update event, which is not reliable, and there's a link. If it's possible, can you please share the detail of that part to me? But it could be offline.
I think this is a question for you, Alex.
I assumed it was for you. I wasn't paying attention. I was looking at the light graph page. Could you repeat it?
Oh yeah, I just want to know that there's an unreliable Kubernetes update event on one of the slides.
Oh, sorry, no, excuse me. It was a question for me. You're totally right. I just misunderstood you. Apologies. You're talking about this bit here, scraping update from it is unreliable. Yes. Is the link not working to this one, or is the link a bit off? Oh, it exists. Yeah.
All right, it's 4132. Okay, thanks.
Sorry about that. Yeah, I totally misunderstand you. Sorry, I thought you were talking about one of the other like events after this one. Excuse me.
Oh, okay. Okay, Sumit, are you ready?
Yes, Alex.
Okay. Let's pass over to you in that case.
Thanks, Alex. Good morning, good evening, everyone. I'm Sumit. I'm principal engineer Intuit, working on something called distributed load infrastructure. And in Intuit, we are using this for many of our cluster. So this is how our scale look like. We have close to 1,000 plus developer, more than 200 clusters, and a bunch of namespaces with many services. Now, if someone wanted to test or someone wanted to create load on this specific infrastructure for their specific service, they are facing a lot of challenges, and that is the thing which we have shared in last year's Argo community. So we build an in-house solution, and before I'm jumping into that, let me talk about the biggest problem what we were facing. First problem, which I think very common across the board, is that scale problem. So when you talk about load infrastructure, how you scale the load infrastructure, usually you have a dedicated instance, or you have probably a certain tool. But again, scaling that is one of the biggest challenge. Cost is also one of the very important thing, because you have to running the cost, you have to owning the cost in the licensing. There are a lot of commercial tools are there. If you go for security and compliance, a lot of integration require, a lot of ACL you need to open. And then those all solutions are not based on the container native or test container based approach. And last but not least, that self-service and automation usually being stuck. Either you go out from your existing pipeline, or you build some custom solution and then you come back to that. So what is distro? So we in Intuit, we are using load testing using this specific tool, which is not anything a specific solution, but bunch of tools will be called as a distro. And it is a scalable container native self-service solution, which is technology and cloud agnostic. Right now, we build solution for one of the Gatling or Scala-based programming and AWS, but it could be pretty easily be ported to any other scenario. And how we do that, I will just quickly talk about that. And I think the way how Pollination has mentioned that they are using reusable recipes, workflows, and the same concept will remain with the distributed load infrastructure. So you have to build a specific programming and container. So we usually use for load testing Gatling as one of the programming, and then we get a container. And how we create a container, Docker container using Jenkins. So you have a container available. Now this container information you provide in the workflow, and then you write the entry and exit point. This Argo, you have set it up on the Kubernetes infrastructure on your specific workload or a specific namespace. Now, again, from the same Jenkins reusable declarative pipeline, you will again invoke the Argo, and then Argo will go and execute this load infrastructure, and then it will try to push all this, because it's many of the execution. It will push the load to the AWS S3 bucket, and then it will gather all the results and consolidate that. This is the way how, if you are moving away from a specific programming, you can bring your own container, and you can use any of the existing Kubernetes provider, or you can, in place of using S3, any of the other data source, and this will work as straightforward. Before I jump in that, this is the blog I have written on this, which talk briefly about the distributed load testing, and all the links are available. And this is the way how you can get started on this specific setup for your execution. Now, why we started doing that? We have two use cases. One use case is for the engineer. So engineer usually have they want everything to be on demand, that they have a service and they wanted to increase the on demand load. They wanted to scale based on the infra. They don't wanted to go and manually change that. So everything should be part of the code. So infra as a code, and they want a self-service so that just they add as a part of pipeline and it should go. We, as we are building this, for us, there is a little bit more responsibility because we need to maintain this infrastructure in such a manner that it will be self-served by itself. And how it can maintain as a part of pipeline. So we probably need to think about that, how we can create a declarative pipeline. And then to get all the specific container images and maintaining Argo workflow, we need to have the security and compliance of the right images. So in nutshell, how this whole thing works. So you have your source code, which is your any of the programming language code. We suggest that along with that, you have your test code and this infra code. This infra code is nothing but those certain YAMLs and all those processes that how you wanted to go and execute your load distribution. Your test code will create a container image, which is a Docker base. And then here on the infra code, you will have this information that what specific Docker entry point or what command line I have executed and how I can parameterize that in Argo workflow. Through this Jenkins pipeline, we just execute those processes and it will go and it will grow based on your demand and supply, that how much load you wanted to give. And beneath the Kubernetes cluster, you have your Argo workflow and Argo UI set it up. Now, once you have this whole setup available through Argo workflow account, it will go and target or hit any specific endpoint. And once the execution is done through workflow, it will consolidate all the results, aggregate that, and then it upload to S3. So this usually give you a power that you bring any kind of test technology and you create a container image. You can bring any kind of cloud provider and you store the data, and rest everything become again reusable components. So let me just quickly jump on a demo first, and then I can quickly talk about the workflow. To do the demo, I have one very simple Hello Nginx application, which just go and execute healthful update. And I can go and then I have to run the test. I have to create a container image. So container image is, so I already have these projects defined, and how I can run the test is I can run and hit any specific endpoint, and this endpoint will give me the execution, whether the test is passing or failing. So if I go and run this, I get okay. So now the same stuff I have put it in one of the test code, and I have a command line which actually go and expose all this information. Now this information I use in my container image. So now my entry point of Docker file will tell that like how I can build this and how I can invoke this. This information I provided as part of one of my Argo workflow. So in Argo workflow, I have given a bunch of steps. First, and these all are best practices which we have learned over a period. But here, this is the important line where you say that you run the test. So when you say the run the test, that time we actually invoke this container image and we pass certain parameter. And what are those parameters? Those parameters are that how you want to distribute your load, where and how this load will be going, and what's the TPS you want, what's the number of nodes and pods you really want. So with that, and how you can just execute this as command line, as simple as that, or you can have this thing being packed as part of Jenkins file. So we have created the Jenkins file, again, is a declarative pipeline. So you don't need to go and write everything. You just import that library and it will just go and invoke. So now I'm just going and invoking one of the execution. Now behind the scene, what it will do, it will just try to grab the container image which we have built as part of this. It will have Argo workflow, which we have coded that. It has certain parameters which Argo workflow want, which we are passing here. And then it has being set up via a context through execution on a specific Kubernetes cluster. So we will be actually executing this on one of the Kubernetes cluster where this Argo workflow has been set it up as a namespace or workload. So here it's asking input. For default, I just use 2 pods. I just want a minimum load, and I just started that. So as I'm running this execution, behind the scene, it will go and it started a workflow on our Kubernetes cluster. So this is one of the example where I showed that. So here it will first. So Argo team has a lot of best practices on how you can make sure that this specific workflow should not be impacted. So we do PDB create, and now here we are actually going and executing the test. So here the test actually started. And through Argo, because the inside, so here you could see that we are actually hitting the endpoint and the test actually started. So we can look a lot more information that what and all those parameters we are, and how we can configure and parameterize those things. So coming back to here, so now what I showed here is that like I pick a test code, create a container image, configure the workflow, and started executing. Now, as we are distributing the load, one of the biggest challenges is that how you can consolidate those results, because every pod will spit a different kind of a report. So for that, the same execution, we have actually added aggregator. So aggregator is nothing, but it will be merging your existing results. So most of the technologies on a container, they usually have a mechanism that if you create a report, you can consolidate. So we use that, and these are the 2 images which is good to start from the scratch. So let's see how things are going. Now, once the test being executed, again, we have integration with the Splunk, and we do have monitoring. You can go and look for the Splunk, which in Intuit we are doing that. But there are a lot of other monitoring aspects are available as part of the Argo. You can look into the Argo job. You could look into that. All other things specific to the monitoring. Wait. So how the workflow is happening. So the overall workflow, as I mentioned, that you have a code base which is there and Git. Create a container image. You have a workflow YAML defined, and everything has been triggered by Jenkins. Jenkins will go and submit a context of Cube. It will just, again, these all things are very compliance thing and security. You cannot have a specific execution. So what we are doing is just with this context, we are only creating the Argo submit. Argo submit will have, Argo has a specific role and permission we have defined, and those role and binding can have execution on a specific namespace. And initially it will go and create a pod disruption budget, then it will execute the test and it will aggregate and put it in the S3. This is the setup what we need on Argo for a specific cluster or a workload. And all those recipes are available on the community side as well as on the Argo onboarding guide. Now, this is the way how it will come up. So here you see that list come, and then we are getting S3, and we should be able to see the report. So this is the way how the pipeline will look like, that you get the execution going, you get your results, and then we do have a 2 integration. One is with the captain. So in case you wanted to define your SLI and SLO, and you wanted to make this execution pass or fail, you can do that. As well as very recently in KubeCon, we shared that how the same workflow can be used as part of the chaos execution. So these were the other 2 solutions which we have built on top of that, where you can build the specific gating mechanism, or you can go and with the execution of the test, you can create many of the chaos experiment also. Now, what's the reward for us and what's the benefit if anyone wanted to use this? because in our scenario, we were using, we are building a platform, and that platform will be used by many of that. So practically it's impossible that one team or one person can go and support all this. So it has to support the platform. So it has to be something which is a self. That's one very important part. As we are building as part of the code, the container test container, so it's become a very container native approach. And as everything is being in the YAML, or everything is being in a container image, everything is being code, you can just add as a part of pipeline. Cost is really important. We compare with any other commercial tool what we are using and we are maintaining, versus we are using Argo workflow and doing all the setup. We have seen in a year time, we save more than 90% while running this specific execution. And again, everything is open source. So to get started, you just need to go and start on the Argo workflow. So I wanted to talk one very interesting thing, because we are doing this because we are eating our own dog food. I wanted to show one of the very recent execution where we have actually run the test. And I wanted to show that how much kind of a throughput we are able to simulate via this. So we are able to hit more than 1,000 nodes on a specific cluster, and we are able to execute more than 70,000 TPS. 70,000 TPS via this Argo workflow load infrastructure. We reach up to 1,000 nodes on a given cluster. Now, if any other way we wanted to execute it, it requires a lot of cost, it requires a lot of resources. Now with the Argo workflow, we were able to do it very quickly. In our clusters, we have close to, I think, 25 plus setup like that. Again, all these things are being set it up as part of the cluster creation. We do have one add-on based setup on Kubernetes clusters, which actually go and set this whole infrastructure for us. So this is the way how we are actually doing, and this is the way how I see going forward. Right now, we are supporting only the AWS-based execution, but we can support Azure and GKE. The only one technology we are using right now, Gatling, but any of the load distribution technology like JMeter, Go, Python, you can create container image and get that. Integration of, we already have that two integration or two open source on CNCF, Litmus, and Captain. We are only right now doing for load, but it could be functional and UI. Right now, we have used a CI integration with the Jenkins, but it could be any of the CI. I just kept for information as part of this, that if anyone wanted to get started, there are a lot of information available. Now with that, I will just take pause and see if there is any question. So this is the execution and this is the job. Alex, over to you.
Actually, if you have 1 sec, I do have a quick question, not related to the load testing, but I happen to get a peek at, it looks like you have a UI for managing clusters at Intuit, which looks really interesting. And I was just curious, is that a proprietary thing or is that based off of an open source project?
Hong can talk about that. Yes, Hong is there.
He is here, but he's not answering. I will answer on his behalf. We do have our own in-house system for managing Kubernetes clusters that allows teams to self-serve themselves, create their own test clusters, install a set of kind of enterprise add-ons related to things like security and logging, so they don't have to worry about a lot of that kind of stuff. And that's got a user interface and audit logging and all those kind of juicy features you want and something like that. I don't think we're planning to open source it, but Hong may be able to answer that.
Yep. For managing the cluster, we use Intuit Kubernetes service management. So, but yeah, Hong is the right person. To get started, it's straightforward. Just go and start here, and all the documentation is available for the reference Nginx base image as well as the test container.
What's test proj, Sumit? What's that?
Yeah, so this is another Git project which I built because when initially we built for Intuit, we figured it out that Intuit has a lot of proprietary stuff. We cannot use that. So we use something which is very generic, use something which anyone can take it and use it. So because we use a GraphQL based execution in Intuit for most of our services.
Okay, any more questions? Thank you very much, Sumit. That's really good stuff. I will now take over. Oh, hang on. I've now got a huge window of people. Let me pop you over there. So if you've been following discussions inside our chat recently, you'll know that we're on the verge of releasing Argo Workflows v3. I'm going to talk a little bit about some of the reasons behind doing that, and then I'm going to talk a little bit about some of the major features. We've always wanted to rename the repository from Argo to Argo-Workflows because people get confused between the two repositories. We're planning on doing that. We're planning on also additionally sorting out a problem with our Go modules that makes it very hard for people to kind of import that code base as a library into the code base. And we're also going to make some small, potentially breaking changes for some other users, including a slightly different way of doing artifacts called a key-only artifact, which I'll circle back around to that if people are particularly interested. So that's why we're gonna do v3. I kind of like one of our main goals with v3 is not intended to be a breaking changes. So we're hoping that it's going to be a relatively straightforward migration for most users. We haven't actually got that many more new features in version 3 than we do in version 2.12, and we do plan to give 2.12 kind of long-term support. But what I want to talk about today really is some of the new capabilities that we're going to put into the Argo server user interface. And I've got a little wiki page here to talk a little bit about those. I think I'm probably going to talk about two main features, and I'm going to talk a little bit about some of the smaller features, and I'm going to do a little demo of those guys. So let's crack on with the meat of it. So people will notice this user interface looks slightly different to the existing one. You can see that the left-hand navigation is a slightly different shade and also has a lot more icons in it. There's about twice as many icons as v2.11 has. And in the bottom right-hand corner, we've got like a new chat button down here. So this chat button is a configurable chat button in the same way that you can configure links in the rest of the user interface. And you can choose to have this point to your kind of internal documentation, or it can go to some kind of external documentation. We found this very useful in Argo CD to direct our internal users to some kind of self-help and FAQ pages that we could keep up to date using kind of a Google Doc kind of thing, and then they can jump into another Slack room for chats. So it's really been really helpful for Argo CD and helping people out, and we wanted to bring that into Argo Workflows. Okay, so the two most major features in the user interface, I think that they're going to be most impactful for people. One is around the introduction of Argo events into the user interface. So we've actually got some new API endpoints for people who are Argo events users. New service called a sensor service, and a new service called the event source service, which I can't seem to see here, but I'm sure it's here. Event source service. They provide a kind of additional set of kind of standard CRUD endpoints for these two types of resources, as well as the ability to stream the data about changes to event sources and also to stream data about the logs. And I'll show you some of that shortly, why that's particularly interesting. An event source in Argo events is an action that basically an event source listens to something and then drops a message onto a message bus. So for example, a Kafka event source will wait for a Kafka message. An S3 event source will wait for a drop into an S3 bucket, and that drops a message onto a message bus. And by default, we've kind of configured it with, in the demonstration environment, it's got a calendar event source, which emits a message every 10 seconds. A sensor in Argo events land is something that listens to event sources, messages that have been dropped onto the event bus by event sources, and perform some actions. And some common actions, again, are things like trigger a workflow, create a Kubernetes resource, drop a message onto some kind of message bus, and that kind of thing. So it allows you basically to use Kubernetes to plumb actions. And you can, in the user interface, we've got a very common, very familiar to people system here, showing you the ability to add event sources. And we've actually got 2 event sources set up in this system, one that logs the events, 2 sensors, one that logs the events that it receives, and another one that triggers workflows. And that's put together in this page called the event flow page. And this shows you a diagram of within a particular namespace of all the events going on there. And you can click this event flow button, and it'll demonstrate as long as there are no bugs, because there are a few teething issues with this, it'll demonstrate the flow of messages through the system using animation. So you can see that at that point there, the calendar triggered, because it triggers every 10 seconds. And you can see that it was connected to the log sensor and the workflow sensor, and you can see that those guys have acted there. I think there might be a bug with animation, but that's fine. You can also click on these, and it'll bring up additional information about that that particular trigger. That's quite interesting, because in the Argo events world, these things tend to be multiplexed into a single CRD. So a sensor tends to contain multiple triggers, but often you only want to see the logs of a particular trigger. And you've got additional kind of diagnostic tools just to see that particular trigger here. It wouldn't show any other information from the logs for other triggers. It filters those ones out. And obviously you've got some kind of events as well here in the background that it shows. I mentioned a bit about kind of improved reliability in the user interface. And one of the things we've done is we've refactored quite a lot of code to use, the user interface is written in React, and we've changed a lot of the code to use a thing called React functional components. And we found that they're much easier, it's much harder to write buggy code using a functional component, and much easier to fix bugs in those components. Bugs can't really hide in too many places. As a result of that. And you probably noticed in the user interface there a second ago, we had a connection issue, and it actually automatically resolved that connection issue. So we've got a lot more code that deals with problems around being disconnected from the network due to unreliable network or some kind of proxy sat in front of it. The user interface is now extremely tolerant to that and typically reconnects you within a couple of seconds. Okay, so I talked a little bit about the events there. Does anybody want to jump in with any questions before I continue? Okay, I won't do that. Okay, let's have a little look at the workflows. So in the workflows interface, we've got a new way to submit workflows from the user interface here. Effectively, you can choose from a drop-down of workflow templates, and it'll take you straight into the submission method. Or you've got a new workflow editor that has a few more options around it as well. So you can edit it using YAML, but you can also edit the parameters individually, and you can actually edit the metadata. And this same kind of editor is now available for workflow templates. You've got it straight here. I'm straight into the editor when I go in here, and I can go through and edit various bits of information very directly in the data here, which I think is pretty nice. If I go into a particular workflow, you can, some of you are familiar with this, will probably notice that the DAG, the graph is rendered slightly differently. And I've got a few new options here at the top left-hand side, looks slightly different. So one of the new options here is the ability to filter by template in the view. You'll also notice the number of icons have shrunk in the top view here. We actually show fewer icons. This tended to have like a lot of icons that would actually end up going over the off the right-hand side of the screen. So that kind of view has been compacted. We've got 2 new icons at the top here. One is a new log viewer. This is a whole workflow log viewer. So previously you'd be able to look at the logs of a specific pod within your workflow. And in V212, you can look at actually the different containers within that pod. In Argo Workflows version 3, you can actually look not only just at the logs of the specific pod, so I can have a little look at the init and weight container logs if they exist, as well as the main ones. I actually get the option of choosing which one of the particular pods within the workflow I want to view, and if I just want to look at a specific one, I can choose that, or I can look at the whole ones. So actually what you can do here is you can watch the progress of your logs as they scroll down the screen. Additionally, we've got a bit of a beta functionality here. If I just click on this guy here, we've now got some, oh, he's probably been deleted. We've now got some kind of a very basic B3 embeddable widgets that you can embed into your application, showing the status of the workflow and of the graph. And that also actually works as well for workflow templates. If I go into, let's choose GitHub events. If I go into GitHub event, I can actually have a look at the widgets here. And these widgets will automatically update as the workflow progresses. We will probably look to improve these over time because they're quite heavyweight in terms of the user interface. And they do require you to, if you're going to embed them in another application, you need to deal with effectively kind of the typical cross-frame issues that you get with those guys here. But these particular widgets here for a workflow template will actually automatically update as a new template is created. So if you've got a cron job, you can have a widget for that cron workflow or a widget for a particular workflow template, and it'll automatically update without you having to refresh the page, or particularly deep link. You don't well, I'll show you. You don't deep link to the workflow, you actually deep link to the particular template. Okay. Now, what else do we have in the user interface? I've covered that. We've got some new links. So a lot of people use kind of deep logging links to make it easier to jump into their logging facility, because obviously pod logs obviously disappear quite rapidly, or maybe you don't have archiving of logs set up, but it can be quite useful to be able to get it into deep links. So you'll notice there was a deep link on this page. There definitely was a deep link in this page. Oh, it's probably not configured on this environment. An additional log link will appear on this page for that one. And if you choose a particular pod, you can actually have another deep link for the pod. And the same for event sources and sensors. If you want to deep link into Splunk or I don't know whatever you guys use, then you can do that. I'm going to show a couple of items from like V2.12 as well for people who haven't upgraded. So we've also got a new workflow report. That's actually in V2.12. That's actually been around for a while. And you can use that to look at historical data for particular workflows. This is not a very good example because no data's appeared. Let's see if we get some data for this one. No data's appearing. I'm not really sure why. That allows you to look at things like how long did that workflow take, how much memory did it use, how much CPU did it use, which is already kind of existing data. It's just surfacing it to the user interface. And we've made a few kind of like small tweaks to the user interface to improve things like, for example, a better layout when the page is resized from a small page to a large page. Okay. So you can go and give that a go. You can actually go and try it out yourself today by going to workflows.apps.argoproj.io, and you can have a look around there. You'll have to log in using your GitHub login. So when you log in, just click on the single sign-on login here and log in with your github.com login and click grant access, and it'll take you in to that interface, and it'll provide you a read-only view of that, of course, but there's quite a lot of seeded data within the user interface. You can see what's going on. Okay. What I also wanted to just talk a little bit about, we've got a few other features. You can come and have a look at what else is in the V3 milestone here as well. We've got scalable controller using leadership election. So you're able to run 2 controllers, and when one is in hot standby, so when one fails, the other one will jump in and start processing that. We're going to fix the support for Go modules. Simon is working on that at the moment. And we've got a couple of improvements around artifacts. So we've got a new thing. We've enhanced the artifact repository reference. So you can have a default one for a particular namespace that's automatically used for workflows in that namespace. We have a feature that will automatically create S3 buckets for you. So if your workflow uses an S3 bucket, you can do that. And another feature called key only artifacts, which allows you to only specify the key or path of an artifact, and all the information such as secrets and endpoints is automatically filled in for you. And those key only artifacts can also be They can also be referenced within a particular bucket. So it allows you to do quite nice things such as have a workflow where you have many tasks all that write into a single bucket that are followed by a subsequent task that actually gets that whole, that whole bucket mounted as a directory, and it can go through and process those files. So it makes fan-in workflows, so like MapReduce workflows using artifacts, much easier to use. Do expect teething issues. It was quite a large code change. We're hoping we can kind of squash some of those teething issues soon. Okay. Now, would anybody like to ask any questions about V3?
This is awesome.
Very, very quick question. Yeah, it looks like really cool. So thanks a lot for the work put there. I'm just double checking and assuming it's the case, but you can still put like parameters and stuff like that into your key artifacts, correct? To modify the classes.
Yes. What I've done is I typically parameterize them using the workflow name. So I give it a bucket, my workspace / the name of the workflow, and then I've got a bucket that's my whole workflow. That's not for anybody else to use there as well. We will probably be looking at 3.1 and 3.2 in providing some new features around artifact management that makes things like fan in and fan out much easier. It's a little bit difficult to do MapReduce with artifacts today. You have to kind of work around it. So we're probably looking to improve that, and also conditional artifacts where the artifact you'll use is actually based on a condition. If step A passed, use the artifact from step A. Otherwise, use the artifact from step B. That kind of stuff. That's not a promise, though. That's a hope.
Yeah, this looks awesome. I had a question around logging. So we definitely have, workflow authors and then workflow users. The authors are very interested in like debug output and all this junk, and the workflow users just want them to work. We I guess want to use structured logging with our Argo workflows. So in GCP, we're able to filter all that stuff out properly. Is there any interest or any ideas around like supporting that kind of use case in like the actual log viewer itself, or is that something you would just like ship it, just make that log button go directly to the GCP log sync, or what do you think about it?
It's an interesting question. One of our developers is currently working on kind of revitalizing the kind of underlying log component is, and I'm kind of aware that it would be nice to have things like structured logging, filtering by time frames of those logs, filtering by log level and so forth. But we can never do as good a job as like a professional tool, because we really it all underlies. It's all underlined by the Kubernetes pods API, kubectl, logs, API. And if you look at that API, it only has a certain number of options. It's not particularly efficient for, you can't say to it, return me only error messages, or return me only certain time frames. So it will never be particularly efficient performance. My suggestion is deep link into your logging facility, or is persistent as well. It goes away with the pod.
Got it. That sounds awesome. The other question I had, so I admittedly, we've been using Argo successfully for quite a while now to automate some workflows that used to run on developer boxes, and it's been great for that. We hand rolled our own little, I guess, like instrumentation around the Kubernetes events that Argo emits, to do things like track things like workflow, like how long workflows take to run and amount of failures and stuff like that. We pipe that over to Wavefront. So I noticed that, there was a little bit of the Argo event stuff going on. I saw some sinks and some emitters and stuff like that as well. I saw some charts showing up in that sidebar. Is that, so am I going to be able to delete that code soon, or?
I guess in a way, we often like start developing features. We lay some of the groundwork for it, and then we see if there's a lot of interest from the community before proceeding with the features. Those charts in the left-hand navigation, my hope is that people will get involved, or they'll come up with new charts that they're kind of interested in, and we'll develop them. It's it's just a bit of JavaScript, to be honest, that loops over the thing. So you could easily come in and add your own chart if you wanted to provide that, and that'd be fantastic.
Also, have you considered trying out the Prometheus metrics features of workflows? So workflows themselves can, as an output of either a step or the entire workflow, can produce Prometheus metrics. And if you want that stuff to go to Wavefront, we also use Wavefront, and we use like Telegraph to pipe Prometheus metrics into Wavefront. And then so what, instead of relying on Kubernetes events, your workflows themselves can say chart completion times and success rates and actually customize your metrics of whatever you'd like to emit as a metric, and then pipe that into Wavefront using Telegraph.
Nice. I'm gonna have to look into that for sure. We just hacked something together in like a day or two, so that sounds like a much much better solution there.
The Prometheus metrics we've had for a while. They're I mean, for operational stuff, that's really the solution for you. So there are things like, average, there are some kind of like deep insights into the controller's behavior. So for example, how long is it taking for the controller to get around to processing a workflow?
Mm-hmm.
That stuff is in there as well. There's also custom metrics as well. I don't know if Simon's here to talk a bit about that. That allows you to build metrics that we emit on behalf of your workflow, but they're defined by the workflow itself.
Awesome. Yeah, that's also stuff I really want to know about.
Cool.
I'll have to look into that.
Okay, we're running. Are we running a bit over time? We are a little bit. I just wanted to kind of close up. We'll be sending out a couple of surveys in the next, maybe even today, but certainly the next couple of days, to gather information about from the community about people's usage of Argo workflows and Argo events. If there's one thing you could do that could make an impact for your benefit, doing this survey is the really key thing for everybody to be doing. It shouldn't take more than like 10 or 15 minutes, and it's the usual kind of questions about what are your use cases, what do you want, what would you like about Argo workflows. But it's just very, I want to really emphasize very highly and very importantly how useful this will be to us if you can complete it. Actually, it'll be very useful to you because it'll help us drive our roadmap over the next kind of 12 months. And I'll be dropping that in